So in the last class we talked about combining salt, filter and unique. So we'll see. Hmm. So we talked about four of the core dynamic array functions already, like sort by filter and unique. But there are two more that I want to cover as well. The first of which being sequence. Now, what sequence excuse, does is it generates either a one dimensional or a two dimensional array of sequential numbers. Syntax wise, it's very simple. Only one required parameter or argument, which is number of rows you want to generate or return, followed by three optional parameters. You have got a columns or argument which allows you to specify the number of columns to return to build a two dimensional array, and can also specify the starting number where the default is a 1. Then the next one is, and then finally you can specify the step or the increment between each number in the array. Again the default being a 1. So to visualize exactly what this looks like, consider an example like this. In this sequence function, here you can see, in this sequence function we are using a row argument of 10, a column argument of 6, a start number as 10, and a step of 5. And basically what that produces or generate is a 10 row 6 column array that starts at the number 10 and increments by 5. So the important thing to note here is that our numbers go left to right first, and then so this is one of those functions in Excel that you will rarely use on a on its own. You might use in the combination, since sequence is almost always combined or nested within other functions to make them more flexible or and even dynamic. So and that's exactly what we are going to show you in the next demo, where I'm going to combine sequence with functions like large and filter to do some really powerful things. So let's go to our Excel sheet. So we know the what the sequence function does. So we have talked about syntax, showing some basic examples. Now let's see one day some demo for this. So now I am in my sequence tab of my dynamic array for formulas workbook. So now the first thing is, let's just use small blank real estate here and get, so you can see, and get comfortable writing some sequence functions and interpreting. So here I'll write a sequence function, and so we could start with a very simple sequence function that just uses the required rows parameter. So let's say 10 rows I want. So here I'll write sequence. So I had press enter, and what's going to produce is an array of values that's one column wide. It starts at 1 and it increments or steps by 1. So we get 10 rows tall, 1 through 10. So if you wanted to produce a two-dimensional array, we could very easily just add a second parameter to the formula and say, okay, we want three columns wide. So what I'll say, I'll add a second parameter. You can see you got a we are still starting from 1, and we are still stepping or incrementing by 1, but we are having three columns. Now we just have a 3 by 10 array that extends from 1 to 30. And last thing here, we can update the final two parameters. Say, you know what, instead of starting at 1, let's start at 5. So what I'll say, instead of starting from 1, I want our Excel to start from 5. And let it be the default this thing. And instead of stepping by 1, I want to step by 20. So you can see, so it has started from 5 and it has stepped from 20. 5 plus 20, 25, 25 plus 20, 45. So we move left to right, incrementing by 20 each time, and then go down to the next row, again left to right, down to the next row, and so on, so forth. So there you have it. That's a basic sequence function and the output that it produces. But like we talked about, it's very rarely used on its own. And the example that I want to show you is here how we can combine it with a large function to extract the top end salaries from some source data. So just like we have been dealing with throughput throughout this project, got the same kind of raw data here. You can see we have got some raw data. We have got the industry column, cities, and the job title, growth rates, and the average salary. So we have got the raw data here. So in the column G, we have to pull out just the top 3 salaries from column D. That is the task now. And to do that, we can use our handy large function. Only two. We need only two arguments here. Large. So it returns the kth largest value in a data set. So large. And the array of value means shift. The second argument is k, which tells Excel I want the first or the second or the third largest value from that range. So in this case, we want the first or the largest overall value. So I will type a 1 for the k parameter. So what I'll do, so it spits out how much 1,55,654, which is the highest salary in our source data. So but here we don't just want the top salary, we actually want to see the top 3. So if we are dealing with traditional Excel, what we might do here is fix this reference copy. So reference, copy the formula, paste it more times, change the 1 to a 2 and then to a 3. So with that we were doing in our traditional Excel. And now we have the first largest salary. So now if you want the second largest salary, what you want to do is say if I change it to 2, we have second largest salary. If I change it to 3, so we have changed the 1 to a 2 and then to a 3. And now we have the first largest salary, the second largest salary, and the third largest salary using these three formulas. But notice what's changing here. It's just that argument from 1 to 3. Only the argument is changing. It's almost as if we are creating a sequence of values from 1 to 3. And that should give you a hint that the dynamic sequence function can be nested in here to make this formula more dynamic. And that's exactly what I'm doing now. So let's uh, delete these two formulas now. Let's clear some space. And now instead of hard coding to 1, 2, 3, here we can give a sequence function. Sequence. And remember, just like I showed you, we basically want to produce a one column array from 1 through 3. So all I need is this first argument here. So I need three rows tall. So I'll give that argument first. 3 rows tall. And then close of the parenthesis. Press enter. So you can see I've got the 3 largest top salaries. So in the traditional formula where we hard coded it to 1, 2, 3, so each and every time we need to copy pasting and we need to change. But now with the help of sequence, now here we can get a 3 largest salary at one go. So 3 rows tall we have got. We get the exact same results using dynamic array functionality and only using one single formula instead of 3. So that's great, but we can do even better. We can make this formula even more dynamic by turning it into a top end calculation instead of fixing it to top 3. So let's actually just copy this formula. I'll copy this formula. So like just like instead of hard coding to 1 like 3 sequence of 3, so here we have a j where user wants to, where we can take the user value. If he wants to know the top 6 salaries, then our formula should fetch that value and it should give us the top 6 salaries. So here a user can actually determine the number of rows and therefore the number of top average salaries he wants the excel to return. So what I'll do, here what I'll say, instead of sequence of 3, I want to hard code it as J5. Yeah, J3, sorry. And you can see we have got the top 5 salaries. In cell J3, we get the top 5 salaries. So now if I change it to 10, so you can see we have got the top 10 salaries. So likewise, it has been the more dynamic. Not, so again, pretty awesome that we can do this so easily using this dynamic array functionality and the sequence function. But suppose we want to take it even further. Using this combination of large and sequence is great, but it limits us. So we can return the top 10 or top end salaries, but we have lost the context here. We don't have the other associated values from our raw data. We don't know which job title it is from, which industry it has, and which city it represents. So, and that's really important context that an end user is likely going to want to see. So how you could do that is, let's start from a scratch here. Okay. So in cell K6, the first thing we are going to want to do is return values from our raw data. That is, from our raw data filtered down based on the salary criteria. So in plain English, what we want to do is return any records of industry, job title, cities, salary, and growth where the salary value is in the top 10. Okay. So let's just start with filter, and we want to return data from our entire range. So, so you can grab everything. So what I'll say, I'll put a filter function here. Filter. So I need to select the whole of this array. Shift control down. This is where it's a little bit challenging. Which records do we want to include? Well, again, in plain English, we only want the records for cases where the average salary is in the top 10. So we know our filter criteria is going to be based on the column D, which is average salary. So let's go ahead and select D3. So our filter column criteria is in D3. That is shift control down arrow. And then what I'll say, this has to be greater than or equal to the, what to say, the largest salary. So here we'll include the large function. Again, the referencing cell would be D3 through D842. And the K value here in this case is 10. Or we can say J3. We don't want to hard code the value. I'll say J3. Close the parenthesis one more time and press enter. Okay, you can see we have got this. So we have got all the columns in that array. So far so good. We got 10 results here. We are pulling the industries, the job titles, the city, salary, and year of your growth also. So the only catch is that it's not sorted to map to those average salaries from high to low. So what we need to do is, when we need to sort a dynamic array, so well, we use the sort function. So we will wrap everything, the whole formula, in the sort. So you can see the sort index is our average salary column, which is the first, second, third, and fourth. You can give the index also. So my index will be 4, comma 4 in the array. So you can see it has sorted according to the average salary. So if you want to sort it by descending order, you can be -1. So sorry, I've given the wrong. It should be comma -1. So I'm thinking, yes, you can see the toppest salary is at the top. I mean, the largest salary is on the top. So we can map or match up our average salary here. And now we have all that additional context also we have. So the top job is an attorney title, which is the in the law industry from San Francisco, and it has the growth rate of 2.1%. So we have got all the context for top salaries, and also, as always, we can adjust this to top 5, top to top 15, whatever we choose here. And if you want top 15, you can give. You can see the same has been added. So really good example of how to nest a sequence function with other dynamic arrays. This one. Now we'll see brand. Now the last the brand new dynamic array function, that is randarray. And what randarray is designed to do is, it will generate a one or two dimensional array of random numbers. It's very similar to a traditional rand or rand between functions. The difference is, as the name suggests, is that those legacy function return a single random number per formula, whereas randarray can produce multiple results. So syntax wise, there is actually no required arguments here. Just like rand, if we left this function entirely blank, it is going to return one single random number. It's going to be between 0 and 1 with a decimal, but that's not much fun. What we want to do is practice actually customizing these parameters to do some more interesting things. So we can tell the randarray function to return a certain number of random values based on a specified number of rows. Default would be 1, same thing with columns. If you want a two-dimensional array, again, default would be 1 column line, and then you can specify a minimum value, a maximum value, and whether or not you want to return random integers or decimals. So the default behavior for those parameter would be a minimum of 0 and a maximum of 1 and decimal values as opposed to integers. So if you do want integers, you would specify a 1 or a true for that final parameter of the formula. So pretty straightforward here. Here is what it looks like in this case. We are using a rand array function with a rows argument of 10 and true. So here you can see we have, so argument of 7, a minimum of 0, a maximum of 100, and a true or a 1 parameter to specify that we only want whole numbers or integers returned, and as a result get something that looks like this. So it's a two-dimensional array, 10 rows, 10 rows by 7 columns of random whole numbers that all fall between 0 and 100. So little pro tip here, random array is one of those functions that you would almost never use on its own unless just you have a fun little like generating new random numbers. So instead it's often nested with other dynamic array functions. Okay, so now let's have a quick example for this too. So, all right, we are in our random array tab. So we are going to talk about creating random top end list using the random array function. So, but the reason is it's advanced is that we are not just using random array. We are going to combine random array with a bunch of functions we have already learned. We are going to use unique, we are going to use sequence, we are going to use sort by. So we'll even use functions like index and rows as well. The good news is that I'm going to break this process down piece by piece, step by step, so that you can see exactly how this is all working. So so if you follow it through up, so you will understand the right one. So here again we have some raw data, the same thing. So we have got industry, job, city, salaries, and year over year growth. And what we are going to do is basically follow 4 steps, right? So we are going to start by returning a unique list of job, easy enough. Then we are going to randomize that list of jobs. Then we are going to pull out one of those random jobs, then make that a bit more dynamic and pull out the top 10 random jobs from that randomized list. So now as if that weren't enough, so the final step will actually to combine all those steps together. So all of those steps will combine into one single formula which will populate right here in column Q. So without further ado, let's go ahead and give this thing a shot, starting with our unique list of jobs. So this step's pretty straightforward. We are going to use our handy unique function. What else? Unique. So I want job title. Shift control right. So you can see we have got our we've got our list of unique job titles. Sorry. So we've got our list of unique job, and if we select all of them, let's see, we have got 84 titles represented here. So step 1 complete, easy enough. Step 2 is to randomize that list of jobs that we just created. So to randomize it, we knew we need to restart that list, but we are not sorting by any field that we have or any logical way, right? We are not sorting alphabetically. We're not sorting by salary or growth rate or anything else. So now we know we need to use a sort by, because we are sorting by a different list. So exist as a field in our array. So let's start here. What I'll say, sort. I'll say. And here where it's little, it's how we are sorting those type. What's the, by here you can see we should give the array parameter in this formula by column by array. And when you think about it, if we could create an array of random numbers that's 84 rows tall and sort by that random set of values, that would essentially allow us to randomize the titles themselves. So the best way to do that is to actually use a random array function right here in this parameter argument and the number of rows. So we can ra- randomize this with the help of rand array. So it could just hard code the 84, type it in. So 84 and press enter. What happened? Sorry, we have to use sort by, not sort. Since in the last class when we discussed about sort by, we saw that if you want to sort any column or array based on the column which is outside of array, so that we can see here. So now we can see that actually works. Give me a random list of job titles, so it's the exact same size as my original spill range. If you scroll down, it is the exact same size as my original spill range, 84 rows tall. But obviously we want to avoid hard coding values in case anything changes in the future. So this has just gave us the random list of the jobs from this list. So if you just press enter, just give us the random list. So each and every time when you click it, it will give the random this thing. So but obviously we want to avoid hard coding values in case anything changes in the future. So instead of the 84, what we can do is tell Excel to return the number of rows in that spill range. So we can actually use the rows function pointing to that same spill range. So here instead of hard coding, I'll say rows. and I'll give the column rows. What I'll say, same thing, shift controls G3. Again I will close the parenthesis. So press hit enter here. So you can see we have not hard coded it to 84, or whatever values change here, according to that it will give us that random rows. So there you go, same results. Now it's just dynamic. And if you want to see this randomized list change, you can use the F9 shortcut to recalculate the formula, or you can navigate to formulas tab and click calculate. So we have formula. So here we have calculate now. So you can see each and every time it is changing. So just to producing the random list of jobs from here. So that's step 2 all done. So moving on step 3, we want to extract just one random job title from our original list. Well, this one's actually pretty easy because our spill range in column I here, all we need to do is just to pull, let's say, the top job from that list. From this list, I want to pull the top job. So to do that, we can use an index function, which we have learned in our array, is that spill range, what I'll say, index. I'll say I3. And in this case, since we are just grabbing one title, I can grab the first row or the first value in that array. Now I want a row array, and then I'll give 1, close it off. That's it. So you can see we've got the here we have got the store manager because it is in the top. So if I just give calculate now, so whatever comes in the top, it will just give that 1. So bank teller, maintenance section, that looks good. Step 3 done. So now moving on, step 4. Let's apply that exact same logic, but instead of retrieving just one random job, let's return in random jobs based on whatever values populated here in cell M2. Okay. So in this case, we want to return 5 random jobs. We can start exactly the same way by indexing our spill range by I3. So I'll say index. Can start exactly the same way by indexing our spill range. And now instead of a row number of 1 or 2 are fixed at any value, we need to make it dynamic. And in this case, since we have a 5 populated in cell M2, we are essentially asking Excel to return the first job in that list, then the second, then the third, then the fourth, and then the fifth. So we want to produce an array that's 5 rows tall by inserting a formula argument or parameter, essentially a sequence of those first 5 numbers, like 1 2 3 4 5. So I gave you a little hint here. So the way we can make this row number argument dynamic is to use our trusty sequence formula, and we can point right to that cell M2, which is in this case. So what I'll say, sequence Then I'll give num starting with 1 with a step value of 1, which are the default parameters. So close it off, two parentheses. And there you go. Now we have got our top, in this case our top 5 jobs. Can randomize it, and we will see that list of 5 updated each time that we recalculate. So calculate now. See, now we have made it through each of 4 steps to produce a random top and job title generator. So now the final step, which is pretty tricky, is to combine all of that into one single formula in column Q. So, and the way I like to do is essentially to work backwards, because each of these formulas are kind of like built on each other. So each of these formulas in the back, if I go backward, they're built on each other. And if we can start from the outside end, we know we want to start with an index function. So we know our index functions referencing our spill range in I column. So we know that column I1 is a sort by function. So here this is a sort by function, not this one. This is, that's referencing our spill range in column G. And we know our spill range in column G is a unique function that referencing our raw data. Since we have all of those pieces now, it's just a function of essentially them will put all together. So let's go ahead and start by copying that index function, what we have. So So I'll paste the index function. This is the index function, right? Once again, I'll be back in 5 minutes, okay? I'll be back.
Okay, ma'am.
Okay. So in the last step, what I'll do is, where is my God. This formula I'll copy and paste it in here. Q. So now if I paste it and if I put enter, what is happening? I've got the same result as column N. But now instead of referencing our spill range and I3, I'm going to jump to I3. So I'll go to here, I'll jump to I3. I3, grab that entire function, everything after the equal sign. So I'll copy this. So I copied and I just pressed enter and back into my Q3. So I'm going to literally just control V in here. So in the place of I3, I'll give I'll give that formula in place of my spill range. Press enter again. And then final step, anywhere that I am referencing my G3 spill range, what I'm going to grab that actual formula. So in this unique, copy and input that in its place. So copy this and I will put it here in the G3. We put the in here also, wherever we have G3 ash, wherever it is giving the entire G column, there and all I'm putting. So and why don't we actually just reference instead of M2? Let's reference P2 here. We have M2 somewhere here. So here we'll give P2. Give P2. Which is the number of random titles we want to return, and then press enter. So it's working. It looks great. And notice that now we are not referencing any of those preliminary steps or helper columns that we needed in the backward. So here, this is entirely independent of all these things. So if we don't have these things, if I just delete anything, then it will not affect this one. So it will not affect that. We're only referencing the raw source data itself. So the ultimate test here would be actually delete all of those intermediate steps. So I will delete all of these intermediate. So still you can see we have this. So this is how we can make it independent of others. So next is so let's talk about the frequency function. Which technically isn't a new dynamic array function, but it's a great example of an old or legacy formula that has become much more user friendly and much more powerful with this new dynamic array functionality. So the frequency function is designed to return the frequency of values in a range based on specified in intervals or bins. Now, if you hear us using terms like frequency or bins, odds, or we are talking about the distribution of numerical values in a data set. And frequency is a great function that we can use to analyze distributions along with usuals like histograms and Pareto charts. So syntax wise, only two parameters here. The first is the data array, which is the array of cells that contain numerical values, and the second is the bins array. This is a array of intervals or bins which we will be used to define how you group or bin those values. Now, important note here is that bins array argument, it needs to be structured in a very specific way. It's going to be formatted as the upper limit of each bin, formatted as a number, and I'm going to show you a quick example of that now. And then again, once we, so here is a simple visual example here. We have got our product category and sales data in column A through C, and what we are doing here is using a frequency function pointing to those numerical sales values in C2 through C10 and telling Excel we want to return the frequency of those sales values or records in our original data set based on the interval specified in cells F2 through F6, and the resulting spill range is going to look something like this. So it will specify how many times it has been repeated in our raw data. So here we are counting the frequency of sales records which fall into each bin represented in cells F2 through F6. So there are 4 sales values or records that fall under $3,000 and 12101. So like that we can have. So now let me go to the Excel. So all right, so we are in Excel.
Hello.
Yeah. So for this demo, we want to have better understand the distribution of these sales value. So sales value. Uh, One second. So here we are in our Excel, and in our tab is frequency. So we are now in the frequency tab. We have got the same familiar raw data that we have been working in with in industry, job titles, cities, salaries, and growth rate. And for this demo, we want to better understand the distribution of these salary values in column D. So what I have done is set up some pre-built intervals or bins which start at 25,000 and go all the way to a maximum of 1,75,000 with intervals of 25,000. So these descriptions here in column G are really just to help understand which values are going to fall into each of these interval buckets or bins. So that is the setup. So here we'll have the bin description. So don't worry now if you're not understanding. So note that I'm using the upper limit of each bin. It's formatted as a number here in column H. And now all I need to do is type a frequency function right here and in I3 and reference those intervals. So our bin, so what I'll say? I'll say equals frequency the array of values that I am analyzing. So I want to analyze this value from D3 through D842, and I can scroll back up. The only other parameter or argument of this function is the bins array, which I have already created here in this thing. So H 3 through H9. Close it off. So you can see the average, this thing we have got some this thing. So I have got my distribution, my frequency of salaries that falls into each of these predefined bins. Okay, and again I get one extra row in case there are salaries in my data set that exceed my maximum. So I have got 0, which in this case would be in any salary over 1,75,000. And this process is very similar to what we would do if we were to simply insert a histogram to visualize the distribution. So if we were doing that, I would select the same data array, right, and go to insert, select the same data array, go to insert, and I would select a histogram here. Histogram. One second. Yeah, here we have. So let's move this up. Cut. Paste it here. Okay. Pasted right here. There we go. And you can see Excel has defined. This is how you can insert charts and all. Excel has defined whatever it deemed to be appropriate intervals or bin ranges here. So what I'm going to do is format that axis and going to basically replicate the same bins that I just so just if I right click here, format data series have. What I'm going to do is I'm format that axis and I'm going to basically replicate the same bins that I just have here created by hand. So my bin width is, so you can give here, bin width is 25,000. So you can see, so my overflow, which is basically my max is 1,75,000. My underflow, which is the minimum, is 25,000. Give enter. So check this out. This has changed according to my intervals. I get the same intervals that I created by hand. I see that there is a count of 3 salaries in the first bin. So you can see value 3 here. I have 3 salaries. Okay, value 3. Next I have 2, 1, 4 in the second, and the 284 in the third. This is I'm saying value. So this is how you can, and that matches exactly to the values produced by my frequency function here. You can see 214282, and we can call this something like salary distribution. This is how you can create a salary distribution chart. Just to make it consistent, give it a nice navy. So if you want to change the color, that also you can do. Title options, text options. Fill. Okay, fill we have. Here in the color we can give the navy. If you give enter, so you can have like this, and you can change the color options also. So text option I want color is in the blue, which looks good, white. Okay, so like this you can change it. So this is how you can insert a histogram chart